Hello everyone, welcome back to our online lab series. Today we will be demonstrating experiment number 3. The name of the experiment is magnetic circuit characteristics. In this experiment we have three objectives. Our first objective is to determine the BH characteristics of an iron core. Our second objective is to find the relative permeability of the core material, and our third objective is to calculate the iron core reluctance. In this experiment we will be using this magnetic core. As you can see, inside this black box we have the electromagnetic coil, and using the left side terminals we will be applying the current and voltage to this magnetic core. This is the schematic diagram of the magnetic core, and the bottom figure represents the equivalent circuit diagram of the magnetic core. When we apply the current I into the magnetic circuit, a flux phi will be produced using the right hand rule. Now let us see the parameters of this magnetic core material, where Lc equal magnetic core mean length, N equal number of turns, A equal cross-sectional area, F equal system frequency, omega equal angular frequency, and mu naught equal ER permeability. As mentioned earlier, when we apply the current I into the magnetic coil, a flux phi will be produced. Also, a voltage E will be induced across the coil that is almost equal to the applied voltage. Then, using the formula available in the manual, we have to calculate magnetic field density, magnetic field intensity, core material relative permeability, and iron core reluctance. This simple diagram is our today's experimental setup, where a magnetic core is connected to a variable AC power supply. Now we connect the experimental setup with our available data acquisition system, for example, isolation amplifier, Profi KC, and KC software. In this experiment, the channel A of the isolation amplifier will be used for voltage measurements, that's why it is divided by 100, whereas channel B is used for current measurements and it is divided by 1. After completion of the circuit diagram and the KC settings, we will be applying 0 to 160 volts into the magnetic core in 10 to 15 steps. Remember, before making the circuit diagram, we must have to check our safety fuses like our previous experiments. Also, while activating the channels in the KC software, we have to select the RMS values as we are going to measure the AC quantities in this experiment. Finally, we will be selecting the manual recording as per the guidelines.
Experiment 3 is on magnetic circuit characteristic. The objective is to find the pH curve of the magnetic core and to find the relative permeability of the core and the core reluctance. As you can see here, we have got a magnetic core, iron core. So very simple setup, and it has got terminals to connect. So we will use two terminals. Okay, the power supply for this, we will pass AC voltage, okay, single phase, that means between one phase and the neutral. So line 1 is being taken to the fuse, and from the fuse we are taking to the OB, okay, and then from UA we are measuring the voltage. So UA will go to line 1 and OA will go to the neutral, so it will give you the phase voltage or single phase voltage. And we have the selector switch for the amplifier at divide by 100 as always for the voltage. Now the current, we are going to measure the current flowing through the core. So it is in series, okay. So we need one fuse, we are using one phase single phase supply here. So the current is here, so we are using two channel, one for the voltage. Channel A in amplifier is for the voltage and channel B is for the current. So we have 1 V over A for the current and divided by 100 for the voltage, as you have seen it in earlier experiments. Now from the amplifier, of course, we need to connect to the Profi KC. So from channel A of the amplifier, we connect to input A, which is UA1. Channel B, we connect to input B, which is UB1, and the grounds together. So that makes the connection. Very simple setup, okay. So the procedure is that we will switch on the voltage, okay, and then we will increase the voltage in steps of 10 and we go up to 160 volts, okay, to get a smooth curve, okay. So after you do the connection, what you have to do, we go and activate in KC, okay, and we put the RMS value because you have the AC voltage and the AC current in this case, okay. So we increase the voltage by 10, we switch on the power supply, okay. So this is a you can control the voltage. So we have 0 and we have 10 and 20 like that, and with every reading we are going to press F9 or the clock in manual recording, and we will get the whole curve. So you go maximum up to 160 volts. You can hear this sound, from the core. You don't have to worry, but at higher voltages it is important that you take the reading quickly, because you don't want to overheat the core, and we will not touch it. It's very dangerous to touch it. So we go up to 160. So that's the maximum, and then quickly after we record, very quickly we will bring it to 0. So we should have 10 to 15 readings at least in order to draw the curve. When you select current as the x-axis and the voltage as this is the magnetization curve that you have seen in the textbook also and in your lecture class. Okay, it has a linear region and then it saturates. Now I'm showing you in the chassis, after you make the circuit connection and before you switch on the power supply, we need to activate the channel. So we are connecting to these two channels in the chassis, UA1 and UB1. So when you click it, from black it should turn red, and we use the RMS value. You see, there is an average value, there is an RMS value. For AC we always select the RMS value. The same thing we are going to do for the second channel, RMS value and close. So the channels get activated. You can see these two red dots at the top, and this is what we are connecting in the chassis, in the Profi chassis. We are using those channels. It's up to us, which channel we can use. This channel also, in that case you have to activate the corresponding channel. Now then you have to define the parameters. Okay, so we have the voltage, applied voltage. Remember, we are measuring the voltage from channel UB1, channel UA1. So you have to multiply by 100, UA1, the symbol is here and the unit is here, and we can give the range, you can always change it. Same thing for the current. Okay, the current we are getting from channel UB1, there is no multiplication factor. So you get the voltage and the current. These are the two things that we always measure in electrical measurements. Okay, now, so after you set up this, you can have in the display x-axis I and y-axis E. There are only two quantities here. Okay, now you switch on and you increase the voltage in steps of 10, roughly, not exactly. I mean, from 0 to 160 volt, you should get at least 12-15 readings in order to get a nice curve. So as you can see, with every reading we press the clock, so it will record, and we get the whole set of readings up to 160 volt. The current the maximum current you are getting is around 2.2 amperes, and here it is close to 160, and we get this curve. So this is the linear region, and this is the, it starts getting saturated here. If we take the voltage further, you will see a flat curve, but we don't want to overheat this and destroy the equipment. Okay.
We are done with the experimentation. Now we have one manually recorded KC file, only one. Be happy. As a part of the report requirement, we have to do a few calculations. For example, this is our equation number 1 from the manual, which can also be represented as H equal K1I. From these two equations, we can calculate the value of K1, which is 1000 turns per meter. Similarly, from equation number 2, we can calculate K2. From equation number 5, we can calculate K3. And from equation number 7, we can calculate K4. During the experimentation, we have measured the quantities E and I. Now, using this formula in the KC software, we can calculate other quantities like H, B, R, and mu R. After calculation of the required quantities, we have to plot E versus I, V versus H, mu R versus H, and R versus H. Finally, we have to make a couple of comments on the plots as per the report requirement. That's all.